I'm Kim Steinhauer, President of Estill Voice International, and I'd like to welcome all of you to our very first Estill Voice Training Research Report, the first of many, I hope. We're fortunate that Estill mentor and course instructor extraordinaire, Helen Rowson, will share her cricoid presentation, and it was met with overwhelming success at our Estill European Summit. Helen is an extraordinary person, and I'm going to share a little bit from her bio, and this is small because her bio is so large, before we start. Helen Rowson is a singer and vocal coach currently working in Barcelona, Spain, London, and Liverpool, UK. She first came into contact with Joe Estill's work in 1996, and since then has worked extensively with the model. She currently runs Estill certification programs for EFP and EMT candidates in Spain and the UK. She has performed and taught extensively throughout the world. Helen has a Master of Science in Vocal Pathology from the University College London, has published her research and was awarded, I just found out, an associate lectureship at the University of Barcelona. Is that right, Helen?
Yeah, I only found out yesterday.
Congratulations. So Helen's presentation will last approximately 30 minutes. Then we'll have a Q&A, question and answer, for about 15 minutes. Participants welcome from around the world. Please keep your microphones muted during the presentations. And now, to tilt or not to tilt, that is the question, Helen Rowson.
Oh, hi everyone, and I'd just like to say thank you for this initiative to Kim and Mary. It's been something that I've been really interested in us sharing any research that we might be doing out there, and this is fantastic. It's a great initiative, and I hope it carries on. So I feel very proud to kick it off. And this was a literature review. Laryngeal Tilt and Beyond was the title. It was quite difficult to come up with a title, but that's the title we came up with. I did the literature review with Andrea Ramirez, who's an EMT candidate, is someone who's quite accustomed to doing literature reviews, so she was very useful to me and had all the access to all the big data banks that at the time it was harder for me to get access to. So I'd like to thank her. She couldn't come today, but I'm just thanking her in her absence. So it all started because we heard of a talk that had been given at the EOTOS Teachers Association in Great Britain, called After Estill, A Conversation We Have to Have. And the title surprised me first because I didn't realise it was all over. I mean, After Estill was an interesting title. I thought we were still going at that point. So I decided I was going to watch this talk, and I did. I watched it while we were in beautiful Quebec. Myself and Charlotte Shorthouse watched it. Charlotte Cherry watched it from beginning to end. And it was presented by Dr. Gillian Keyes. And this is how it started. Whoa. Okay, so she started by putting this picture up on the board, and she said, so what is tilting? She was talking about Estill, talking about tilting, and so this was her question to the group. What is tilting? And this was the rather interesting drawing she put up. Rather an unclear drawing. Source Ron Bacon, who's a writer of big tones on acoustics and measurements. And as you can see, the drawing she's put up shows the typical tilting of the thyroid, lengthening of the folds, but it's a very unclear drawing. And then she put this slide up, and this is a drawing that she quoted as from the Voice Clinic Handbook by Tom Harris. In fact, it's a drawing that originally came from Netta, from that lovely, great big book of anatomical drawings that we all used to use before the internet gave us so many beautiful 3D alternatives, but it's a great book. And this was the picture she put up. And her comment to go with the picture was, not everybody tilts the same way. And I looked at this picture and I thought, well, it looks like the cricoid's tilting backwards in order to lengthen and thin the folds. Is that what she's saying? So this really hooked me in, because I could see this diagram. I've seen it before, obviously, when I'd looked at Netta, but I hadn't actually taken that on board. I hadn't seen that, or I hadn't remembered it. So by that time, I was well hooked into Gillian's talk. So she claimed there are two possibilities for stretching and thinning the folds, she stated. She then stated, some singers do it one way, some singers do it another. This opinion she put down to Tom Harris. This is what she said he'd said. In fact, when I looked at the book, Tom Harris's book, he'd said, tilting the thyroid cartilage forward on the cricoid arch produces rotation about the axis of the cricothyroid joints, lengthening, thinning, and increasing tension in the vocal folds and posterior cricoretinoids. The converse is equally true. The arch of the cricoid ring may be tilted up towards the lower margin of the thyroid cartilage laminae with identical effect. That's according to the book. So it's a little bit more complex than just some singers do it one way, some singers do it another. And also, really, you can't make that assumption from that paragraph, I think. But that surprised me, because I actually hadn't taken on board, when I used Tom Harris's book, the Voice Clinic, that there was the possibility of the cricoid cartilage tilting up and back to lengthen and thin the folds. So I sat down with Andrea and I said, I want to have a look at this. I want to see if there's any more literature out there that talks about the possibility of cricoid tilt. We talk about the possibility of cricoid tilt, but for shortening and thickening the folds, not for lengthening and thinning. So this is something I wanted to see if there was any more literature out there, or if this was just one statement from one book that that Dr. Keyes had picked up and run with. So we did a literature review, focusing on articles between 2014 and 2018, so we get the most up-to-date research that we could get our hands on. But we did look through previous articles. We reviewed about 50 different articles, so that took quite a long time. And we got out our books. I got out all my old books, seminal texts such as The Science of the Singing Voice by Sundberg, The Principles of Voice Production by Tietze, the Voice Clinic Handbook, Tom Harris. I reviewed all the books I had on my shelf. And while this was going on, I gave an Estill course. And one of the beautiful videos from the Universidad of Lyon in France that I use is this one for the anatomy and physiology section of the Estill course. Now, I hope this is going to work. I just want you to, this is the video that I use on my courses. It starts after a couple of seconds. So you get beautiful pictures of the larynx in 3D. Beautiful animation, so you can see how the muscles work. This is great for people who are starting. It's wonderful videos. The actual explanations in Spanish down here. And that's the bit that interested me, because, oops, has it stopped? Because you could see the movement of the oh, it has, it's blocked. I'll try it again. I won't stop it this time. You could see that the cricothyroid muscle is actually making the front of the thyroid cartilage move up towards the front of the thyroid cartilage and not the other way around. So I'll leave it running. I won't stop it this time. Here. So that was the movement that was being shown on the video that I was showing my own students in the Estill courses, taking away some layers and showing that the tilting of the thyroid, front of the thyroid cartilage, the front of the cricoid cartilage up is actually lengthening and thinning the folds. So that was interesting. Moving on. So then I went to the books. And this is what I came up with from the books I had, and there are many more books, but these were the books that I had on my shelf. Forward tilt of the thyroid cartilage enables the vocal folds to be stretched longer and thinner. And that was from Singing in the Actor by Gillian Keyes. And it's actually the only one of 2 books that state that it's the thyroid that tilts forward. The other one was Care of the Provisional Voice by D. Garfield Davis, which is a very old book that no one uses anymore. Stretching and thinning the lips of the vocal folds. The science of the singing voice. If the cricothyroid muscles contract, they move the anterior part of the cricoid cartilage upward and backward. So that's Johann Sundberg. When the cricothyroid muscle contracts, the cricoid cartilage pivots, rising in front and lowering behind. That's from a book called The Voice and Its Disorders by Leslie Matheson, which is a kind of Bible for speech and language pathologists in Great Britain. The cricothyroid muscles draw the cricoid cartilage towards the thyroid cartilage. But here we have or vice versa by Ingo Tietze in the Principles of Voice Production. So there again, rather like Tom Harris, he's saying either could happen. And in Tom Harris's book, it says whether you regard the cricoid cartilage as the fixed structure and the thyroid, I've missed the H out, the thyroid cartilage is the lever acting around the fulcrum of the cricothyroid joint or vice versa is immaterial. He says it's immaterial. But the majority of these books were actually saying that the cricoid moves up and the plate moves back, and that's what's lengthening and thinning the folds. The dynamics of the singing voice. The cricothyroid muscles pull the thyroid cartilage forward, another book that says it's the thyroid cartilage, and tilt the cricoid cartilage backward, thus elongating the vocal ligaments and increasing tension. So that's the dynamics of the singing voice by Meredith Bunch, and I think that's it. So that was the books. So then we went on to a series of articles, 50 papers that we read. And these were the 4 articles that really our literature research ended up being based on, the 4 sort of major papers that had been brought out in the last 4 to 8 years. Chan, and these names will come up again and again, Chan et al. Well, they were doing a study into into the efficacy of cricothyroid approximation for trans women, so operating on people, trans women, to give them a better voice function after the sex change. So they'd come up with the backward tilting of the cricoid plate occurs in the cricothyroid joint, backward tilting of the cricoid plate. Forick et al. In 2017, the movement of the cricoid cartilage could be visualized. Unteregger et al. In 2017, lengthen and add to the tension of the vocal fold by tilting the cricoid plate posteriorly. And then the cricothyroid muscle causes a backward tilting of the cricoid. That's Stork et al. In 2017. I will send everybody a bibliography so that you can look at all these articles yourselves, but that was a resume of those 4 major articles about lengthening and thinning and movement of thyroid or cricoid, and they all said it was the cricoid that moved. So how did they see this? They were using computer tomography, or as was known as CAT scan, now it's called a CT scan, which makes use of computer processed combinations of many X-ray measurements taken from different angles to produce cross-sectional or tomographic images, virtual slices of specific areas of a scanned object, allowing the user to see inside the object without cutting. So that's what computer tomography is, and that's what they were using to visualize. I'm just bringing you all back up again. That's what they were using to visualize the movements. So, and this is how they visualized it. This drawing is the result of using a very sophisticated software called Mimics, which allows you to see this 3D image on the computer screen of the object that you're observing, having done the CT scanning. And so you can see one position of the cricoid imposed upon another, and see that this is vocal process 2, vocal process 1, the anterior commissure. The length of the vocal folds is the distance between the AC and the VP, and that with the cricoid in the backwards position, the vocal process of the arytenoid has moved backwards and the folds are longer and thinner. The drawing's a little bit confusing in some ways, but they're just showing that it's a very clear image that they get, and they can clearly see that the cricoid has moved in that way in order to lengthen the vocal folds. So that's CT scanning, and a couple of the articles were basically about proving that this was really a very efficient way to observe movement. So that's, I can see it, there you go. So that was 2 or 3 of the articles made that point, that it was a very efficient way of viewing this. So what else did we find? One article in all these articles, which we took out, Young and et al. In 2015, because he did talk about rotating the thyroid cartilage down towards the cricoid, but because he was talking about differential contraction between pars recta and pars oblique, we thought it was a very interesting article. He had observed that contraction of the pars recta results in rotation, but contraction of the pars oblique results in forward and backward movement, and that's something that will come up again a bit later in the presentation. But we thought that that was an interesting article in itself, because it divided the 2 bellies of the cricothyroid into 2 different functions. So we took that article out as well, and there is the picture of that happening. So here you've got the pars recta, which would cause rotation, he thinks, in the thyroid, and the pars oblique, which cause the forward and backward movement of the cricoid. So those 2 things we'll look at again in another slide. So leaving that behind, while we were reading all these articles, something else came up that we hadn't considered, that I'd never heard of, and I found fascinating. And this was that within all these articles, they were talking about joint types. So suddenly we don't all have the same cricothyroid joint. This was something I'd never heard of before. So we looked back in the literature, we went back, and found right back in 1971 with a kind of a landmark research by Maui, and I think it's pronounced Maui, I'm not sure, and Dixon, had established that there were 3 types of cricothyroid joint, A, B, and C, based on the structure of the surface of the joint. This hadn't been analysed in any clinical context, but there it was. And then whizzing quite a long way forward in 2010, Hammer and his group identified a difference in joint mobility between A and possible BC joints, so making 2 very clear differences. Joint A had a very well-defined facet, and therefore was capable of greater mobility. 2010 was a big year for joint types. Windish et al. Actually established that there's a percentage occurrence in human beings of these joint types. You find joint A in 61% of the population, joint B in 8%, and joint C in 4%. So that would mean that around, if only 60% of the population have this well-defined joint, what are the other 40 doing? And then in 2010, Stork et al., it was already a familiar name, established the effect of joint type on elongation of the vocal folds. He found that that there was a quite large percentage greater elongation in subjects that had joint A than joint B or C. So the joint did affect how much you could lengthen and thin your folds. The problem with all those, all that research was that all the subjects were cadavers. And that brings its own problems because, as we've seen with Kerry's research with cricoid, what you can do on a dead body doesn't necessarily mean that it'll happen when you're looking at live subjects. So moving on, there was a whole second tranche of research into joint type. Chan et al., another familiar name, looking again, he was working with trans women using 3D imaging, computer topography, established a relationship between the cricothyroid joint type and voice pitch elevation in trans women. The point being they want to elevate their pitch, and this is more or less successful depending on the CTJ type. So if the operation is successful depending on the joint type, then obviously they need to find out whether you have the joint that makes the operation worth having. That was the idea of that research. In 2017, Forick and et al., by now we're moving on to singers. Up until this point, a lot of this research had been done on trans women, their operations. So this is actually 10 female singers, 5 sopranos, 5 altos, 3 pitches. They further established the efficacy of the imaging, of using CT imaging to assess cartilage movement, and established the efficacy of the Mimics computer analyst software to process these images. And they came up with 2 conclusions. Elongation of the vocal folds, a result of 2 actions. They were quite clear about this, and there was no grey areas. Backward tilting of the cricoid cartilage, and adding in, and this was the first time we came across this, inward rotation and rocking of the arytenoids. They also found a significant difference in elongation between joint types A and joint types B and C. So coming into 2017 again, Stork et al. By now they've got a much bigger cohort, 49 female singers, 2 octaves. They found that in the frequency, fundamental frequency to F1, so that's first octave, all 3 joint types showed equal elongation, but when you move from the second to the second octave, type A was considerably more able to elongate the folds than type B stroke C. So this carried on. So joint type is clearly important in the ability of a subject to elongate the folds. And this was the computer topography image of the 2 joints. I don't claim to understand them entirely because I don't know the anatomy of that part of the cricothyroid joint well enough, but you can see they're very different. It seems that it's this uninterrupted surface, like you're not having this protrusion, which is causing the problem, making it less a joint that doesn't work as efficiently. So I put the drawing in so that you can all look at it yourselves. But yeah, the main thing is that they could see very clearly the 2 different kinds of joint with CT scanning and Mimics software. So then came up another subject within the same bunch of 8 to 10 articles, and mainly the last 4. Rotation versus glide. This actually, some of this information came from an article by Pullen, a lady in New Zealand who was interested in some previous research that had been done about anterior posterior movement of the cricoid cartilage, not just rotation. Her question was, is the elongation of the vocal folds only a consequence of the CT space closure, i.e. rotation of the cartilages? I'm just going to take that down. So looking back at cadaver studies that have been done around this subject in 70s, 80s and 90s, they'd only measured pitch increase or vocal fold lengthening that occurred as a result of CT space closure, i.e. only rotational. Pullen went on to observe in vivo studies with ultrasonography that showed some gliding movement in an anterior posterior and craniocaudal, so the movement can be up and down as well, can occur. And the conclusions that she came to in this study, which is a brilliant study, it's in the bibliography, rotational and horizontal gliding movements combined cause a significantly greater elongation of the vocal folds than using rotation only. So also that gliding may serve as a function of individual anatomical variation in the cricothyroid joint. So type A allows a greater gliding movement. So we're back with the idea that depending on the joint, you get more or less movement. So that's rotation versus glide. And again, another subject that came up while we were basically looking at the question of which cartilage moves to lengthen and thin. Pitch control came up. Back to the study by Young in 2015 using video fluoroscopy, which isn't as considered to be as clear as the CT scanning, but that's what he used. He compared vertical elevation and cricothyroid distance during pitch raising. And he came to the conclusion that upward movements of the larynx have more effect on pitch elevation than the cricothyroid distance. So larynx position as a pitch control mechanism being more important than the movement of either of the cartilages, which was interesting. And then 2016, Unteregger and et al. Using tomography, again, CT scanning with their 49 trained singers. This is a study that we've already looked at. Concluded that regardless of joint type, from the fundamental frequency to the first octave, the only observable movement is backward cricoid tilt. Also, that trained singers achieve the first octave of pitch elevation by simple cricothyroid approximation, cricothyroid muscle contraction, the first octave. From the first octave to the second octave requires a complex movement of the arytenoids. So this again was a new element that had been introduced in, and that the arytenoids move first passively as a result of cricothyroid muscle contraction, and then by contraction of the lateral cricoarytenoid muscle. So, hang on. This is the CT scan showing what they meant by that. That there's actually a movement in the second octave. The important thing is the movement of the arytenoid in two possible axes. One, it's difficult without my hands to actually show it, but they rotate in that way, or they rotate in that way. Yeah. So you get a view of a backward tilted arytenoid cartilage with two positions of the cartilage rocking inward around the axis G. Yeah. So they can rock in, and medially around the virtual axis H. And that's what gives rise to facility in the second octave, arytenoid movement. So the lateral cricoarytenoid muscle becomes important then. That's from Forick et al. 2015. Carrying on with the idea of pitch control, 2017, Forick, all these familiar names coming up again, further established the efficacy of CT imaging to assess cartilage movement, and using this mimics computer analysis. This is ongoing, so they're constantly testing the material they use to process all these images. And he came to the conclusion that the elongation of the vocal folds is a result of two actions: backward tilting of the cricoid cartilage and inward rotation and rocking of the arytenoid cartilage. That's it. And that there is a significant difference in the possibility of elongation between types A and BC joints. Very important. And finally, 2017, Stork et al. Concluded that the stability of the CT joint CTJ directly influences the vocal folds during singing. So the cricothyroid joint type will influence vocal range. And that was the last of the studies we looked at. So we're actually missing 2018, and I haven't had a chance yet to see if these people have come up with anything new in 2018, but I was hoping to try and add in an update because I'd like to see what they're doing, these people now, how far they've gone with that. So the general conclusions to kind of bring all that together. The majority consensus seems to be that the vocal folds are elongated by the anterior arch of the cricoid moving up towards the thyroid. That's the general consensus. All agree that the cricothyroid notch narrows. So the mechanism and the muscle strategy are the same. The efficacy of this movement depends on the cricothyroid joint type, whether A or BC. Further elongation of the vocal folds for higher pitches, first octave, second octave, beyond, requires additional rotation of the arytenoids in towards the midline and inferiorly so as to lower the vocal processes, and the joint type will affect this movement. In addition to cricothyroid muscle contraction, the contraction of the lateral cricoarytenoid also contributes to pitch change. And in addition to the rotational movement of the cricoid cartilage around the CT joint, there is horizontal and vertical gliding, and this may have an effect on vocal fold elongation, and joint type may also affect the efficacy of this movement. Pitch may be more affected by laryngeal height than by cricothyroid distance. And that's it. That's the conclusions that we kind of, they came to kind of put together as a group. So, of further interest, how can we predict joint type? I kind of had a fantasy that we would be able to tell what people's joints were before they had the operation, which would not be successful if they had type B or C. I'd be really interested if there was any way that we could figure that out just by using the figures or listening, or that would be fantastic. Of further interest, the whole question of thyroarytenoid versus cricothyroid dominance, which was something which used to come up a lot in research, is not supported in any of this literature. Of further interest, pitch versus register, they never talk about the thyroid cartilage in terms of register, it's always in terms of pitch, never in terms of quality of sound. Bringing in the next of further interest, what about quality versus range? This never comes up in their research. What about the vertical dimension of the vocal fold? They never talk about that, they just talk about elongation. And they never mention any EMG studies, electromyographic studies. So these were things, there were many things in these papers that as we went along, we thought, you're not doing this, you haven't said that, this is missing. They're fantastic papers, there's great information in there, but there's a lot missing, which is why it would be fantastic if loads of people read them, because things that we missed, somebody else would pick up on, that maybe were missing, that were important. And as Estill teaches, how do we move forward with the thyroid figure? Is the CRY strategy still applicable? What about people who feel their thyroid move? What about people who don't? Does our muscle training in Estill help to overcome the initial disadvantage of joint type? Well, that would be incredible. Thank you.
Helen, Rowson, fab. Yes, from around the world, a clap for this really interesting research. You brought up, again, it was clear, it was informative, and it leaves us with many more questions. I always start my course with a hidden agenda, but if I say it out loud, it's not hidden. We need more of this. We need more of the research to, again, support the Estill voice model and voice in general. And Helen, this is a great, great, great start.